Hello, everyone. Thank you for attending today's webinar with Streakwave and Baicells. I am joined by Majdi, where he will be addressing today's topic on Baicells' upcoming 5G products. This webinar will be recorded and we'll share afterwards with a link to our YouTube channel. If you have any questions at all during the presentation, please type them in the Q&A section at any time, and we'll get them addressed at the end. Majdi, you can go ahead and begin.
Great. Thank you very much. Good morning, everyone. In today's presentation, I'll take you through some 5G basics and principles, and I'll walk you through some of our upcoming 5G products. Baicells, we're a global company. We do exist in more than 55 countries, and we have over 40 global partners. We're end-to-end solution. We have EPC deployed across the world, and we've shipped over 200 devices and 100 small cells, 100,000 small cells, and the list is growing by the day. All right, so 5G, I mean, this is a buzzword you hear every day. So what is 5G? 5G is the 5th generation wireless system. It's based on 3GPP standards, release 15. Every 10 years, we have a new wireless generation. And as you know, humans, our generation is 30 years. So the wireless technology is 3 times faster than our generation. So if you're 30 years old, you've already witnessed 3 different wireless generations. 2020 started deploying the 5G wireless technology. 10 years ago, 2010, LTE came to light. 2000, we have the 3G and so on. There are 3 basic components when it comes to 5G. The first one is enhanced mobile broadband, which is EMBB. The second one is URLLC, which stands for ultra reliable and low latency communication. And then we have the MMTC, which is massive machine type communication. So if we look at the triangle right here, if you can see the mouse, let's start with the EMBB. This is all about speed and throughput. 5G speeds, they're 100 times faster than the speed of LTE and 10 times faster than LTE Advanced. So we're talking about 10 gigabits per second. Just to put it into perspective, you can actually download a high definition movie in less than a second. And you can stream 8K movies without any delay and so smoothly. So as we go down this triangle, you can see all the use cases right here, 3D videos and work and play in the cloud, augmented reality, and the industry automation. So as we go down, speed would not become as important as latency. And latency it's the accumulation of various delays from when a request is sent until a response is received. So you can see here, vehicle to vehicle, that's where the URLLC comes into play. The delay or the latency here for these kind of application, it's less than 1 millisecond. Humans reflex, it'll take around 250 milliseconds for the brain to comprehend and react to any event. So when we talk about 1 millisecond, that means your vehicle will be able to decide 250 times faster than you do. So this is just to put it into perspective. Then let's go down this side.
from
the AMBB all the way to the MMTC, which is the massive machine type communication. What's important here for these applications, where there are smart cities and the smart homes, it's the density. In 5G, 5G technology will be able to support up to 100 devices per square meter. That's like 10 devices per square foot. So, the density here is much more than LTE. And we've all been in a situation where, if you're in a stadium or in a crowd, sometimes you don't get the service that you wanted it to. But 5G will eliminate this issue. Another factor is the system spectral efficiency. 5G is much more efficient than 4G or LTE technology. We're talking about 10 bits per second per hertz, and currently we're probably at 5 or 7. So it is much more efficient. And when it comes to energy efficiency, it is like 90% improvement over LTE. So these are the three basic concepts that you need to know about 5G, and all use cases will be covered under these three concepts. Some of the 5G RAN characteristics, one of them is millimeter waves. According to physics, the higher the frequency, the shorter the wave. So for frequencies above 30 gigahertz, that's where we get the millimeter wave. That's the length of the length of the wave itself. What's good about these waves, they pack lots of data, but they cannot travel far because of the short wave characteristics, and they are not as good in penetrating walls. So there's some kind of limitation here. And so that's the millimeter wave concept. Then to utilize such millimeter waves, we use small cells. Small cells, they're going to be spread across the cities and metropolitan, and they're going to be part of the street furnitures, lights, and side of the buildings, and you will see them all over the place. And they're so dense, so every 250 meters you will have a small cell. What's good about small cells, they have small antennas, so they won't look bad. They're not as big as the traditional micro or macro cells, and they'll be spread across the city to be able to utilize the millimeter wave. Another concept is the massive MIMO. Massive MIMO, as you can see from the picture, it's like an array of hundreds of small antennas. Utilizing this feature will definitely increase the capacity of the mobile network. We're talking about at least 22 times. So it'll really put the whole city into another canvas. Another function here is the beamforming. And instead of just randomly broadcasting the signal, it'll be focused on the user itself, and also the technology would allow the beam or the signal to be tracked. It'll track the user, and that will definitely reduce all the interference. It will provide a much better end user experience. So these are the four main characteristics of 5G RAN technology. We have another feature in the core, which is network slicing. Think of it as end-to-end service, and each slice is dedicated to some kind of vertical or dedicated service. You can see, for instance, here, you can have a consumer slice where you can have, postpaid customers and prepaid customers. You can have an IoT slice that will address different verticals, whether medical or industry or utilities. And then you can have the MVNO slice or the WISP slice. So this has been utilized in the core, and it'll make the service, because 5G is service-based technology. And this is how it's utilized. You just have different slices, like a big pizza. You slice it according to the use cases that you're working with. This slide is a holistic view of both the LTE technology and the 5G. You can see on the right, this is where the 5G technology, you can see lots of small cells, because this is how you're going to utilize the fast speed. Small cell will carry 80% of total traffic. And it's going to be indoors. Outdoors, you still have the normal micro and macro with the 5G technology, but they will not deliver the millimeter wave and the gigabit of speeds that you want. 5G small cells will utilize this. Another factor also for another entry for the 5G, we call the edge cloud, or the mobile edge computing, due to the if you have an application where latency is extremely important, you put that server close to the edge, meaning close to the site, instead of having it out on the cloud, because latency is extremely important to you. So this is one of the advantages of 5G. Yeah. Now the RAN part is divided into 3 different units. So this is important. This is part of the 5G Open RAN standards. So the RAN is divided into a radio unit and a distributed unit and central units. And this is spread across all the layers. The OSI layers, you have the physical layer, then you have the network layer, and then you have TCP/IP layer. So if you look at this, we start with the radio frequency, and then you have the physical layer. It's divided into low and high. So, and then you have the MAC and the RLC and the PDCP, and then the RRC. This is where the data starts flowing out, and it's the TCP/IP layer. 2 splits that are of interest here, split 7 and split 2. Split 7, this will split the physical layer into 2, and it's called lo-fi. And what it means that you will have 2 separate hardwares, the RRU, the radio unit right here, and then the distributed unit and the centralized unit would be in a different piece of hardware. If you have the option 2, it means you will have the RU and DU unit functions combined into one piece of hardware. And then you have another piece of hardware, it's the centralized unit. Why we're doing this, in this will make virtualization easy. It will, depending on your application, you will be able to scale the hardware and software according to your needs. And for option 7, this will give you a front haul. This is the front haul would go from the radio unit into the distributed and centralized unit, which is the BBU. This would be realized as a BBU. And the front haul will be significantly higher than the normal. It'll take you up to 100 gigabits per second. But when you split on two, that will give you some limitation. In the split two, this is the mid haul. You have front haul, mid haul, and the back haul. So mid haul, this is a new concept. It's just designed for 5G and Open RAN, and it is the interface between the DU and the CU. And it's done like that because it's open interface and you can actually mix and match. You can have a radio unit from a vendor, another, and the BBU from another vendor, because with these standards, it's open interfaces, and that's the basic of Open RAN. Again, this is from Open RAN and Baicells. We're part of the Open RAN consortium, and just to put things into perspective for you, this is the RRU, which is represented in the Pico radio unit right here. And then there's a front haul. The extension unit is just a switch or an aggregator if you have more than a radio. And then it'll take it front haul all the way to the BBU, which is in this function, the BBU here in this case, because of split 2, if you remember, sorry, split 7, you will have both functions, the DU and CU, combined into one piece of hardware, which is the BBU. And then you backhaul everything to the core network. We do have end-to-end demo system that we're providing to some of our customers. And 5G has two different modes, standalone, which is it's SA, or non-standalone, which is NSA. Standalone, it's just pure greenfield 5G. No LTE components, no legacy is to be dealt with here. So you have the 5G radio, then you have the 5G CPEs or terminals. They're connected to the, remember, 5G is a split. You don't have it in one node anymore. You have the RRU and the BU with the CPRI, eCPRI connection, which is an optical 25 gigabits of connection. In case of 5G, in case of LTE, you have the CPRI, which is 10 gigabits. And then you backhaul to the 5G core. So this is a standalone demo system end-to-end that we provide to our customers to do their own tests in the lab. Now, this is another demo system that we provide end-to-end. This is the NSA, non-standalone. And as I indicated, for non-standalone, you will have LTE parts from the core perspective. Because, you know, to evolve from 4G to 5G, you still want to utilize the existing legacy network, core network, that is, which is the LTE. So in this case, we have a radio that supports 4G and 5G, and it goes into a BBU that has both cards, you know, one for 5G and one for 4G, and then you backhaul it into the legacy core. So this is how, for instance, you know, AT&T or T-Mobile going through their 5G deployments. But for instance, Dish Network, since they have a greenfield 5G, they don't need to worry about you know, legacy, and they will go with 5G straight. Here are some of the 5G elements that we have. We have the new generation core. or APC, and this combines both 5G and 4G. It comes in 3 different flavors. The compact can handle up to 5,000 active users and support 500 sites. The standard configuration would double that, so I'll take you to 10,000 active users and 1,000 sites. And then we have the professional that will multiply the standard by 10. So you will have 100,000 users and 10,000 sites, just within one box. BBU, we have 2 kinds. We have the Intel-based x86, and this can be used as a standalone, for only 5G. And the configuration can be either CU or DU or combined, depending on the split that I explained a little bit earlier. And we have the 1588 version 2 synchronization also implemented in this box. Now, there's another technology for the BBU, which is ARN. This can serve both worlds, the LTE and 5G, because you can add cards. You can have 5G cards that'll handle the 5G radios, and you can have also the 4G cards to handle the LTE cards. So you can expand it and scale it accordingly, and it will serve both technologies. Here are some of the indoor 5G radios that we have. We have Gamma. Gamma is for 5G now. We have the Nova and the Neutrino, so we still use the space naming convention. Whenever you see Gamma, this is 5G compatible. So looking at Gamma 632, these are they're indoor radios. They're dual mode, meaning LTE and the new radio 5G sub 6 gigahertz. Yeah, and 5G has 2 frequency ranges, FR1 per specification. So FR1 frequency range 1 is frequencies below 6 gigahertz, and then you have frequency range 2, which is FR2. This is for millimeter wave, and it's for frequencies above 30 gigahertz or so. The antenna diversity is 6 transmit and 6 receive, and the single channel output power is 250 milliwatts. And since it's 5G technology, the difference in bandwidth, for LTE, the maximum bandwidth you can utilize is 20 megahertz. And for 5G, it'll expand to 100 and all the way to 400 megahertz per carrier, per channel. And that depends on what's called new, which is the numeration. It is configurable in the system. Now, the frequencies that this radio operate on, you can see it's FDD and also TDD. And when you see N, that's a new frequency, it's N41. And what's good about 5G technology, there is a spectrum sharing. So the same spectrum, the same band can be shared by LTE and 5G. N41, this is for the educational band. 5G on band 41, and then band 78. This is a C band, and it starts at 3,300 all the way to 3,800 megahertz, and so that will include the CBRS band within. So you can actually have 5G for the EBS and the CBRS bands. We have another one here, A33, and this it's a dual mode as well. It handles LTE and it handles both frequency ranges. So the sub gigahertz, sub 6 gigahertz, and the millimeter wave. Antennas are getting bigger, so we're going into the massive MIMO. It's 8 by 8, 8 transmitted receive diversity, and you can have it like 2 sectors, 4 by 4, and it's 200 milliwatt of power per channel. And the spectrum, you can see now we added band 261 and 269. And that these are the bands for the millimeter wave. They're like it's used by tier 1 operators here as well. We do have also outdoor 5G radios. The Gamma 844 and 8443 and 84XX. The difference between them, they will have more MIMO. If you can see here, this is 8 by 8. Then you can see it, we're going to 16 transmit, 16 receive. So this is more towards the massive MIMO technology. And the output power, the first one we have it at 5 watts, and then we take it to 40 watts and all the way to 80 watts. So you have more powerful micro outdoor radios available for you. And again, since this is 5G technology, this is no longer an integrated small cell. It's split into 2, the radio unit and the BBU, as I explained in the slides before. And we're adding different bands as we go on. And this is some of the other radios that we're working on. We have the AAU. AAU, it means that the antenna is included in the radio, so you don't need to buy external antennas. The antennas are included. Again, we will have more diversity in all the way up to 64 by 64. This is the massive MIMO, and the power also here, it's 10 watts per channel. Let's go into one of the radios in a more detail, and I'll make it as simple and as quick as possible. We have the Gamma 846. Now this radio, it has the antenna included, and it is one of our products that we're offering for RDOF that meets the RDOF requirements and exceeds it. It is dual mode, so it will work on LTE and 5G. It is 8 by 8. It is the diversity is 8 transmit and 8 receive, and we call it 8 by 5 watts because we have 8 different paths, and each path is 5 watts of output power. L cover band 5G in 41. As I said, anything with the letter N, that's 5G related band, and the classic B48, the CBRS on the LTE technology. It is when it comes to carriers, LTE, we can aggregate up to 4 carriers, and each carrier is 20 megahertz, so you can have up to 80 megahertz of bandwidth on LTE. And for the 5G, it's 1 carrier, and each carrier you can have up to 100 megahertz of bandwidth. It's compact. It is less than 8 kilograms, which is like 16 or 17 pounds. It has 8 CPRI configurations, which means, again, the CPRI is the front hole between the radio and the BBU. And if you remember the split 7 that I was talking about, this is for the 5G eCPRI, which is 25 gigabits per second optical interface. Some of the antenna gain is 10 dBi, and we support the dual mode, and we support beamforming, as I explained earlier in the 5G characteristics. You can actually track the user and have a focus the energy on that user instead of just broadcasting it all over the place. It supports the DU, which is the split, which is the BBU, and it's GPS supported, and 1588 version 2 of synchronization. Other components, if you remember, I mentioned that the BBU, we have one version of the BBU that comes with cards, and these cards are called acceleration cards. And this card can be 5G or 4G cards that you add to the BBU. And this card has 6 interfaces, 6 eCPRI interfaces, and it is PCI Express or ePCI. That's the type of hardware that's being used for these BBUs. Then we have what's called an extended unit. This extended unit, it will connect more than one radio, because you remember we have the radios and we have the BBUs, and then you need some kind of aggregator or a switch in the middle to be able to connect more than one radio to the by a frontal to the BBU. And this model will have 8 optical connections. You can connect up to 8 radios, and then you will connect the BBU through one optical connection, and then you have another connection to another extended units, like you daisy chain them together. But this is to make you able to scale according to the needs. So it's very much scalable. Good. Now, just to protect your investment, we have 5G migration path. So looking at the first layer here, these are 5G radios. And if your configuration, this is for the distributed systems, the radio unit and the BBU separately. It's called distributed systems, no longer one small cell in one enclosure. So currently, if you have the the 4G BBU, which we call Norma 1000, and these radios that I talked earlier, that I mentioned earlier on, and then you need to go to 5G. You don't have to climb the towers and change the radios. They're 5G ready. But if you have Norma 1000 and you need to have the full 5G support from the BBU perspective, all you need to do is just add another BBU 5G ready. So the Norma 1000 will take care of your LTE network, and the 5G for pure 5G subscribers. And the APC, it's just software upgrade, so you don't have to worry about any hardware. This is another way of protecting your investment when you go through complete 5G upgrade. If you already have the x86 server with a 4G cards, all you need to do is just add 5G cards into this server, and you're there. You're fully 5G compatible. Your network is 5G compatible. Again, the radio units, they're 5G ready, but you have the BBU that also need to be 5G, and to be able to do that, you can add just a 5G card, and then you will have your non-standalone architecture that will support both 4G and 5G. And the APC is just software upgrade. You don't need to worry about any hardware. So by doing so, Baicells would really protect your investment, and you don't need to climb towers and change radios and do all that to be able to have the 5G capability. So this is purely future protection for you. We do have roadmaps that we track, that we're adding more features as we go on. We don't have to go through this, but we do have clarity when it comes to future technology. This is just an example of how you can scale your indoor network. If you look at this, this is like like a standard Wi-Fi network, where you have the radios. Consider them as access points. You can connect them to the extended units that we talked about, and this is a front haul to the 5G BBU, and you backhaul it to the 5G core. Now, each BBU can support up to 4 cells. Consider each one as a cell, and each cell can have up to 32 different radios, indoor radios. This is an outdoor coverage architecture. We do handle heterogeneous networks. We do have outdoor AAUs that you can find on towers, and then it connects, as we talked about, it connects to the BBU via the extended units through the CPRI or eCPRI front haul, and then we backhaul everything to the 5G core, whether it's on a cloud or virtualized or localized. And we do have also some indoor solutions and outdoor AAUs that's all connected together. Now, it's worth to mention that we're fully compliant with the RDOF, and they're 5G ready, as I explained in the previous slides. We do have 2 different products that meets the above baseline of 100 downlink speed, 20 megabits of uplink speeds. This is the RAN part, which is split again. This is the BBU, and this is the RRU, and it has all the features, all the whistles and bells that's needed to take you to the requested above baseline speeds, and it's 5G ready. And then we have the Cat 15 that will go with that product. And it'll take you up to 320 megabits per second of a downlink and 28 bits per second of an uplink. And to be able to achieve these speeds on the edge of the cell, the radius is 5.6 kilometer, which is like over 3 miles of radius achieved with these speeds. Then we have the gigabit architecture, which is the LT. We call it LTE Turbo, which will take you to the gigabits of speed. This is it will aggregate. Now, this is not 5G compatible. This is 5G compatible on the top. But remember, to be able to have 5G compatibility, you need to split the radio from the baseband. So this will aggregate CBRS channels to the Wi-Fi 5 gigahertz in order for you to achieve gigabits of speed. And we use also CPE that will take advantage of that LTE technology, LTE turbo technology, to aggregate the CBRS channels with the 5 gigahertz of channels. And it is 2 kilometer of radius edge to be able to achieve these speeds. And that's all for me. And I'm open for any questions.
Great, thank you. There were some questions that are coming through and that also came in the beginning of the presentation or mid. So I'm going to just go ahead and start in order. Is beamforming already commercial available or still development?
Say that again. The what is available?
Is beamforming already commercial available or still development?
It is under test right now. It is available and it's being tested out in the field. Yes, it is available, and that will be also part of the RDOF strategy that we're chasing here.
Okay. Next question, is slicing done only on basis of APN, or is there another way to utilize sizing?
APN based, yep.
Okay. What is the use of a TX power 40 watts if UE is only 2 watts? 2W. The UE cannot cover so much. Can the UE cover so much distance?
Yeah, I mean the 40 watts, that's 8 by 5 watts. So you can actually, each channel will have the 5 watt power, and it's configured. And it's 4 by 4 MIMO. So depending on again your engineering, it will be used. This is according to the standards of CBRS. I mean, you have CBSD Cat A and Cat B, and the maximum powers are considered on these specifications that we provide. So there's a difference between the CPE power and the E0B power. So the CPE is based at the customer side, but the E0Bs for the external ones, they're away from the site. So that's why you need more power on the radios than the CPEs.
Okay. What channel size aggregation is needed for Wi-Fi turbo?
Yeah, it's 20 megahertz of LTE and up to 80 megahertz of the Wi-Fi 5 gigahertz technology. That will take you to, when you aggregate them, in theory, they should take you, the throughput should be close to 2 gigabits per second. That's theoretical. But in practical, when you aggregate both and use the special assignment frame of SA1 or 2, that'll take you to the 1 gigabits per second of upload and download. So.
Why is the max distance radius limited so much when using B48 and not millimeter waves?
Say that again. Say that question again, please.
Yes. Why is the max distance radius limited so much when using B48 and not millimeter waves? Sorry.
Correct. I mean, this is. I explained this earlier. This is according to physics because the band 48 is band 3.5 megahertz, which is like a mid band, and the signal travels further than the millimeter waves. Millimeter waves, they're short waves, and they cannot, by physics, they cannot travel further than the standard mid band wave. So this is just pure physics. This is the characteristics of the waves itself.
Okay. And then was there going to be any discussion on 5G CPEs?
Yes, we are working on that. We are actually we started the design of that, and we should be able to have 5G CPE ready for test earlier in Q1.
All right, thank you. It looks like those were all the questions that were asked. So thank you for everyone that attended, and thank you for Majdi for presenting today. If there are any other questions that do arise, please reach out to Streakwave or
Yes.
Baicells, and we will be also sending a copy of this recording to everybody. Any last minute things that you wanted to add, Majdi?
Not really. I mean, I hope this is just the basics of 5G and our expected products. And if you guys are interested in more detailed explanations or detailed presentations, I'm ready also to take you through more technical explanations for 5G. And please feel free to ask any questions that might come up later on.
Perfect. Thank you again. Have a great day, everyone.
Thank you very much. Bye-bye.